Hello, this is Mr. Wyrick. I'm here to talk to you about lesson 8.6. This would be the law of sines and the law of cosines. A lot of information here, but it has very specific uses. So make sure you're following along. You may need to pause the video, take some stuff down, go back, watch it again to make sure you're understanding it. But until you work the problems, again, kind of like the sines and cosines, it's hard to just explain it without going into numbers, so I'll try to do the best I can here. With the law of sines, this is how you can solve for everything that's missing, every measurement that's missing in a triangle if you are given angle, side, and angle. In other words, if I'm looking at this one, they gave me A, they gave me B, and they gave me this lowercase c, the side that's in between those two angles, or any kind of combination where they gave me the two of the angles and the side that's in between, okay? Once I know that information, the law of sines then is a ratio, and it's a common ratio. The sine of A, this capital A, this angle right here, over the opposite side from it, is equal to the ratio of the sine of this capital B and the small b, the side opposite that angle, which is equal to the sine of C and the side opposite that angle. So if we're given angle, side, angle, we're told that this one is 45 and this one is 85, then all we have to do, and say this is 7 over here, all we have to do is say, okay, if we have 85 and 45, that's going to be 130 degrees. So out of our 180, that means this C is 50 degrees. So any other side we need to solve for, we can use the law of sines here and say that the sine of 50 over my measurement of 7 is going to be equal to the sine of 45 over my A, my length of that side there, and I can cross multiply to find the answer there, which is equal to my sine of my 85 degree angle along with my lowercase b, my side opposite that 85 degree angle. And once again, I can kind of scoot this over here. Doesn't matter where they are if they're all equal, and I can cross multiply using this one and come up with an answer. Now you see, because it's a proportion, it's all these similar fractions, that the larger angle should have the larger side that goes with it, just like we learned earlier when we were first learning about triangles. Key thing about law of sines is it's not an efficient way to solve a right triangle. It's a good way to solve a triangle that is not right, that is acute or obtuse or something like that. You can use then this law of sines. Even though sine really is a ratio that we want to use when we have a right triangle, the sines of these angles are going to match up to their sides all in that same proportion. That way we know with the measurements that we have, that triangle is going to close up and be a real triangle. Okay? The law of cosines, on the other hand, is what we are given if we have two sides and the included angle there. So there's any different number of ways that this can go together. Either a squared, this side, is equal to b squared plus c squared. The sides, just like we're doing the Pythagorean theorem, but we subtract 2 times b times c times the cosine of this c, the opposite, I have that wrong, cosine of a. Okay? Whatever side that we are trying to isolate over here. Okay? We'd have these two sides, we'd have this included angle, or no, we'd have B and C in this case. We'd be given, like B is 4, C is 7. Okay, and the Pythagorean theorem, we know, only works with right triangles. This is like an adjustment to the Pythagorean theorem that makes it work for all triangles. So 7 squared plus 4 squared minus 2 times 7 times 4 times the cosine of A, this angle right here in the middle of it. All right? If we have B, if B is what we're trying to solve for, we have the A and the C, and we have this angle here. So whatever side angle side you have, you will set this up to solve for the opposite side from the one angle that you do have, because that's the one that you could find the cosine of. So the angle that you are given in this information is going to be what you use to determine how you set this up. Try not to overthink this one. I'll help you out with some specific examples when you come to class for this one. Just understand, and you can remember this however you want to. It's the Pythagorean theorem with -2 times the sides that you have and the cosine of the angle that you have. You can use this to find all the missing measurements. Now, one thing you need to make sure you copy down into your notes, other than the law of sines, the law of cosines, page 592 has what you need to use to solve any particular triangle. Okay, page 592, that how to solve given whatever. Make sure you understand that. Make sure you can do every single one of those and you understand why you use what you use. Okay, the numbers that I want you to work for this assignment, 12 through 42, and then 46 and 56 will be the assignment. This should be the day that I'm gone to a tennis meet, so hang on to the assignments until I come back. We'll grade a whole bunch of stuff all at once. We'll get through it. Thank you for watching.